Yes, partly. Partly because I've actually found it easier to work with in general. So let's do boxing on trains tree. Yes. Okay, so that's how you parse that line. Where the D is where you see that alpha alpha get stuff, alpha alpha squad transpose. That's the expansion of the D getter. So we can replace that with D anywhere you see it. So this is a function definition, but the way it's composed together is using these function trains, which have atops and forks. And you can play with this if you want in your own code. You can read about trains in the dialog documentation and play with using it. What I have found is that if I restrict myself to in a disciplined manner to only stay in the trains notation here, then what I can do is I can eliminate another abstraction level. So I've eliminated the barrier of defining functions and defining values. And instead, all I'm doing is defining functions. And so now when I read my code, I can read it almost as if I'm reading expressions. I'm no longer reading a separate set of things. I'm just reading expressions. And so it becomes as easy to read as regular expressions are to read. And so this is where we compose it all together. So we start over here, and we run each compiler pass until we get to the end. And it's flattening it out and working on it. And I've got a paper that you can read that shows some of the fundamental data types or data structures that are used in here, such as path matrices, stuff like that.
Where does RN use?
What RN does is it registers the R field. So it registers.
There, where is it used?
It's the first pass of the compiler. So that's the entry point into the compiler. And then there's a 2-letter code for every other compiler pass, and the 3 letters in there are prefixed by the 2-letter code to which they belong.
Are these each full passes over the ASP?
Yes.
So, just general question, do you have a garbage collector, or is it just basically based off of?
The code defunds language can be implemented using stack-based allocation. And so like the C++'s, I don't know, they call it first. Yeah, something similar to that.
Okay. So I mean, like if you had large binary involved with data, that would.
It's stored in the heap, and it's stored in the heap and managed. Visibility is managed by the stack, and so at the end of a stack frame, those are freed and collected. So exactly like C++ vector types might be used, or any other object type might be used that's stack allocated in
C++.
C++.
Imagine stuff is stupidly fast because you have no control flowing, no recursion, so you basically.
Potentially. Asymptotically, some of these are slightly more asymptotically complex than their brethren. So some linear passes might be n log n, but that's because we have to do it on the GPU in parallel. And there are linear dependencies that have to be dealt with in certain ways.
So each function defines a pass of the AST, but when it actually executes, are those fused into like one single pass?
Not right now. They could potentially be. It's an open question how much that fusion would gain us. So that's future work. And also, interestingly enough, it is possible to automatically derive the asymptotic complexity of this compiler.
How?
Well, if you have a function that's big O n, and you have another function that's big O n, and you want to run after the other, what's the complexity? 2n. If it's together, so you have a function that's composed with another function that runs it multiplying, it's n squared or something like that, or n to the n or something like this, right? I only have that kind of composition in this compiler. And the asymptotic complexity of every primitive is known.
So for the HCI part of this, I don't mean to take you away.
No, yeah.
For the HCI part of this, how long did it take you to be able to sort of look at a source file like this and really just be very confident?
That's a good question. I don't have a specific answer for you, but I will say that I struggled a lot getting some of this implemented in a more traditional style and eventually went to this style out of desperation in some sense. It was easier. I was able to solve the problems a lot better. Yeah. Now, it did take many, many iterations to finally say, oh, this is really what's working for me. So I started with documentation that was 500 plus pages for the parser to try to deal with APL's notation and come up with a very, very specific semantics or behavior for everything and really map it out down to the token level. And it was like, nah, didn't work. So the smaller it got, the easier it was to work with. I started using defunds. Okay, that was easier, but then recursion got in the way because there was certain stuff in there. Then I realized with the path matrices, which we can demo a little bit later, that I was able to do all of that with just this plain stuff. And then it became much easier to work with ASTs and much easier to process things. And so then I was able to write this stuff fairly easily.
So what about the criticism that, I've heard other people talk about, J applications or white noise, and that other languages are sort of more verbose, lend themselves much more readily to other people being able to sort of take up your code and run it.
Right, right. So there's a few questions in there that you have to unpack. Yeah. One, what's the definition of readability? What do you care about?
So I like it.
Yeah, but there's a few things. One is, do you want your people coming in to have to learn 10,000 lines of code or 100 lines of code? Do you want to be able to read a single line of code in a second, or are you okay taking an hour to read a line of code? Then you have, do you want a single piece of code to be easy to read, or do you want the whole code base as a whole to be easy to read? So there are trade-offs there. Certain compilers like Clang attempt to make single small snippets of code easy to read. But understanding the whole architecture of Clang requires extra documentation. Understanding the dependencies and how code flows through the system and all of the dependencies that are there is very complex, even though you could read a single piece and say, oh yeah, that's easy. Here, it's the opposite. One line might take you a little bit to really see what you're getting in, but seeing how it all flows together and fits together is much easier.
Is there something you said also for not having novices come to this and break it? Or in other words, the time that's spent sort of learning right?
Yeah. Well, yeah, so I'm of the mind that don't fool yourself into thinking you know how a code base works.
Sure.
So my view on readability would be, how much are you willing to bet that you make a change to that code and it won't break? That's my definition of readability. Less than, I think I know what this is doing. I kind of have the idea, but until I run it and compile it and see what happens, I won't really know. I'm willing to bet much more that a change here, I'll be able to figure out whether it's going to break or not, than in other systems where I don't really have the ability to see the whole thing and understand the whole thing. And that's where I think the big difference is people focus on readability at the micro level rather than readability at the macro level. And one of my goals, one of the things that comes out of working in this style is that I'm much more willing to expect certain things to work. And if they break, I really know why, as opposed to complex systems which have emergent behaviors that are very difficult to debug sometimes.
So related to that, so for example, Haskell has this loose saying that if you compile it, it works.
Yeah.
Is the same thing similar to apply here?
Similar. The response would be, don't write broken code. Now, it's funny because most people think that's impossible. I might weaken the statement a little bit, but it's much easier to imagine 2 pages of code that you're convinced are not broken than 500 or 5,000 lines of code that are not broken.
Right. And then for the Haskell side of it, just because it type checks doesn't mean it's correct.
Yeah. So typing is an interesting one because I actually a previous version of this compiler to check for correctness. I was following a formal semantics process where I annotated the pre and post conditions of my various stuff and determined what were the correct behaviors to find a type for them, basically. Now the problem is that I discovered that to type one of those lines in any way that was useful to me, beyond just, oh, it's an int or a float, okay, you've got a type error. Something useful like, oh, you're not balancing your tree, or oh, you're not tracking these things. To write those types, it was like 7 lines above, 7 lines below, 1 line of APL. At that point, having the ability to do that it was no longer useful because it was easier to reason about the code directly than it was to use the types to reason about the code. And so I find that to be a good metric. If I can push so that types are no longer useful for reasoning about my code, then I think my code is pretty simple. That's a sort of a metric I play with. And if I feel that I could use a type system to track what's happening in my code, then maybe I should try to simplify the code a little bit.
So if you give something an array as opposed to work on an int, for example, is it blow up on you, or is that?
This?
Yes.
I'll get errors if you get you can get these sort of silly type errors. Yeah, that won't get caught statically. They'll blow up at runtime.
Oh, they do blow up at runtime.
Yeah.
Okay.
The thing is those are easy to find, easy to fix. It's the more complex errors that are harder to find, harder to fix, and that you really want a type system for. Everyone can track down I'm using an int a character instead of an int bugs. Those are easy to track through a program. I forgot about an invariant somewhere in my code 7 passes up, and I'm dropping an AST somewhere that it shouldn't be because I'm assuming something above. Those are invariants that you want a type system for. So that's why I'm much more friendly to dependent types than, say, regular C types or something like this. Because your runtime checking is usually good enough to find the easy stuff. The harder stuff is more. So yeah, and then after this, we just go to a flat space where I dispatch on, the result is a flat space where I can just in parallel run generators on this whole thing and do it. Now, an interesting situation is what do you do when you have to work with C code and you're used to looking at code that's that dense? And believe it or not, this is actually a problem. If you have to jump back and forth between code that's airy and code that's very packed, it can be quite difficult. So what I do, I want to find a simple, let's do more canonical stuff. There we go. Is I write in a very dense C style. Also called the Whitney C style. But I work in a very dense style that mimics the density of APL so that I can reason about it at sort of the same level. And I use a style that mimics APL structures. So that when I'm jumping back and forth between APL and C, I don't bust my mind. Now this might not be indicated and recommended for people to do everywhere in their C code, but it does have benefits. But yeah, so this is one approach, my interpretation of things, but I think Morten has some fun demos that we might run through. And of course, you guys should continue working on your problem sets, but I figured I'd show you some code that's a little bit more complicated than what you're working on right there, and see how it works.
What is this?
That's just a sort of mathematical convention. I'm saying this is equivalent to that, which is equivalent to that.
Wait, I don't get it. Isn't this like the W combinator?
That's commute. That smiley says commute, so it's a selfie.
Yeah.
Oh, you guys didn't know we had selfies in APL, did you? Here, I'll show you what the selfies are. So, we have commute, right? So we can do 3 commute 5, right? Minus 3 minus commute 5 flips it around, flips the arguments, right? But we can also apply it to itself, which is a selfie, which turns out to be really interesting because, for example, we can take 20 random values like so. Then we can apply the find function to itself. And what do we get? So there are lots of little selfies that you can do inside of APL that turn out to be very interesting little computations. So does that make sense?
Oh, I see.
Yes.
Maybe you should put it on 2 lines.
think if I was fresh and I had an hour to go and sit in the dark room, I could do the bracket.
Yeah.
I don't want to try.
You shouldn't. The brackets is a tricky problem, so you shouldn't feel bad about.
I'm not going to offer to live coding.
But it is it's a tricky problem. But it's one we played with at the Iverson College recently,
I think
which
it
is why I
is.
wanted to.
I think there is a way to do it with some inner products and some outer products.
Yeah. So what you're looking for is ways to find overlaps of depths. So if one of the brackets, basically you need to look at your boundaries. So if one of your boundary cases for one of them overlaps a boundary for another, you're in trouble. So what you have to do is look for, because you've got those depths, and those depths represent a certain sort of greater than or less than thing. So if one of them starts here and then suddenly shifts in size and value, you have to flag an error. And you don't have to pinpoint the exact place where the error occurred. All you have to do is identify that something happened. So for example, finding a mismatch parenthesis is just looking at the end tail. And then you have to scale that up a little bit. So yeah. It's a little bit tricky. But it's all right to skip that and just try to parse, try to use parser combinators, or it's all right to try to run the parser or do whatever. If you feel tired and you need to get back to it, you might try playing with some other stuff, come back to it so you can sort of get a little bit more exposure, and you're not just spinning your wheels on a single problem.
You need to identify all the transitions and then look at what the other level is. But you need to find them matching. Yeah, they might not be next to each other.
So I now have a vector of vectors for all my strings.
Nice. Excellent.
I want to
Personally, I would have processed that with UTF-8 first to get the text values instead of the byte values, but yeah.
I thought I had to convert it to that. I can always convert it back.
Because you can work off the text. You don't have to just work off the bytes. You can work off the characters if you want.
Okay. Trivial.
Yeah.
I wanted to drop
Yeah.
the new line, so like everything's prefixed with 10,
Yeah.
right?
And you have 10 at the beginning of every line.
Exactly. So
Right.
I thought I should be able to use this drop.
Right. That's the
Because
right
it's a
way to
vector
go.
of vector.
Yeah.
But am I invoking this wrong?
Yeah. So there's a rank error because that's expecting a vector of rank 2, but that's a vector, so its rank is 1. It's just got a depth of 2. So what you actually have to do is go in on the depth, which is what each will help you do. So what you really want to do is you want to drop 1 off of each element in the vector. Yeah, rather than dropping 1 off of. Now there are other ways to do that, but you can.
I thought this 0 in the front allowed me to basically go into each vector and drop off.
No. So the way that drop would have to work is if I have a 3x3 array, then I can do a 0, 1 drop. But the restriction is that the number of elements I have here must match the rank or the shape. So I can't drop 2 things from something that only has 1 shape, because the resulting shape is basically 3x3 minus 0, 1.
A vector of vectors is not equivalent to two dimensions. Okay. In some languages, they pretty much are, right?
Right.
In APL, they are very different.
Okay.
Right. You can convert back and forth between them. So like this guy, you can convert by dropping the monadic split. And so what that does is it takes one of the dimensions and converts it to depth.
Oh, that's interesting.
And you can also take, which converts one of the depths to an added dimension.
That doesn't help me because it's variable length string. Right.
Yeah.
So you didn't need to do it wrong.
Yeah.
So how does each work?
It's map. For the moment, just think of it as map.
It's map.
For the moment, just think of it as map, yeah.
And the APL primitives are really divided into 2 very, very different groups. There's the scalar functions, where the map is implicit from plus something like
Ooh, hey, that's not bad. Looks good.
It looks like sometimes empty line goes back up,
They are not scalar.
and that doesn't make sense to me.
Oh, really? Let's see what you have. So you're running it? That's okay, so you run it. What does your garbage function look like? All right, so you're taking the count of weird, reshaping it. Why are you reshaping the count? Oh, because you want to. Oh, so.
To go back to the size.
An interesting way to do that, yeah, okay. So you get one less to shape it along that, right. Catenate on the next one, then rotate along randomized, and then you negate the whole oh no, that's in the front, okay.
Yeah, I negate to.
So.
Yeah, so I add the word characters at the bottom, and then I rotate.
Yeah.
So
that's the right idea.
The top.
That's the right idea. But you're doing only by 0 and 1.
Yes.
Because you're getting your range on 0 and 1. So you get 0 and 1 if you negate. Yeah, so they're actually, it's just what's happening is sometimes they don't drop.
Yeah.
So sometimes they drop by 0.
Feels like sometimes it jump up.
That's a visual trick. So if you either made them jump, yeah, so that's just a visual trick. Yeah, it's a trick of the mind, because when some of them stop, it changes the perspective. Like when you see a tire on the highway and it spins one direction and suddenly it spins the other direction. Yeah. But yeah, that's pretty close to, that's the right general idea. Yeah. Yeah, excellent. Very nice. Who else is working on Enter the Matrix? How are you doing on it?
I'm just thinking about the next step.
Okay. Okay. If you think you're about ready, because I think he's basically gone through Enter the Matrix. So if you're pretty close when you get finished with yours, or you feel like you're good, I can show you our solution.
Okay.
You can see what it looks like. Okay.
I think we have until about 5. There's a keynote in here at 5:30. So
Oh.
we can't run until
It can't run until 6:30.
6:30.
Okay.
So we have an hour and a bit,
Okay.
and then we should find one more.
All right. Cool.
I'm going to take a little break and try and double check that so we don't get thrown out.
Yes. I did that. And actually, if you guys want to take a 5-minute break, just grab some coffee or something like that. That might be a good idea too. How are you guys in the middle doing? Yeah? You making any progress?
Yeah.
Right, cool.
What do I parse the data into?
Anything you want. So think about how you might want to parse it. Yeah. We're going to do a little bit of playing with different types of data structures and nested structures when Morten gets back.
Okay.
So yeah, I think I'll have him show his XML demo.
Cool.
Yeah. I need to find some soda.
And that's a throwback to the old mainframe days, where originally we used teletype, right? So we always had the log on the paper, and then the strings arrived and people really missed having the log of what they did in the previous session. So we still have that. And it's actually very useful.
Yes, I like the logs. Yeah, so you guys have seen some stuff. You worked on some problems. I recommend if you continue working on this, you read the paper on the tree processing. You read, well, you just keep reading. Yeah, pretty much. The domains have a lot of fun stuff that you can play with on them. And you can, but I don't think we have time to go into any more detail on it in the official point of view. I'm going to be here the rest of today and probably maybe a little bit of tomorrow. So I'd love to talk with you guys offline about any questions you had. I'd like to say go forth and make disciples of all programmers, but I don't know if we're quite there yet. But I wanted to see what you guys were thinking, where you are in your code, what was difficult, what was easy, what are you thinking? I also, we didn't really get enough time to discuss how you integrate this into a wider framework. So I think I would like to put some papers out that you can read about that. I mentioned it a little bit earlier, but there's this concept of direct development, which is a style of agile-ish kind of programming where the development loop has become a dot instead of a cycle. And in that, your customers are working with you on the code. And the code might look a little bit more like what Morten has shown you. But basically, the idea is when a customer has a problem, they come to you, they show you the problem, and then you work together immediately to fix the problem. There is no separation. Maybe it goes through QA checks that are automated as you go through. But the idea is if you can write your code in the right way, specifically variable name, if you can make sure your variable names make sense to your users rather than to other programmers, then the users can look through the code and oftentimes they won't see the symbols. They'll just see what they can read and they'll be able to sort of track the flow of the values through and determine whether or not this looks like something they need. And you can play different things like mapping the and reduction onto a word called all or any, if that's part of what they think of. So for example, if part of the question is doing queries on data, and one of the things they want to know is, are all these things true? Then that all word might be one of your user domain things. And so instead of writing and slash, you would write all, because that's now in the user domain space, and you want to have a word for that. But the idea is that you keep your names as much as possible into the user space, do pair programming with the users on parts of your code. Some parts they're not going to touch, but parts that the consumer cares about, the parts that they're actually working with, and that they're in control of the logic for, things like this. Rather than having a separate spec that then has to go through design and implementation and analysis and this sort of stuff, why not just have your code be the spec and let them work directly on the code? And this has been used successfully in various pieces, and you can use that to integrate some of these ideas into wider workflows. And then also the CodeDefense compiler, you can play around with that in your own time as well. There's some instructions online, and I'm happy to walk you through how to use it. The idea is the code that you're writing right now, this style, the idea of the CodeDefense compiler is to make it possible for you to play around in dialog and then fix that function using namespace and then get a version that will execute on the GPU or in a compiled version and play with the performance of it, as well as give you the ability to do other things like that. Other than that, I don't think I have anything more to mention, but I'd like to hear from you guys what you're thinking of. I know you're probably all quite brain dead by now at this point, but yeah.
What's the community like for this? Like, as far as tools and support from developers?
Yeah. Well, so it's interesting. There's an active, but I would say kind of hidden community, because a lot of people are working behind NDAs when they're working with this stuff. So there's a lot of passion for the language, but oftentimes you're not going to get a lot of libraries or other things out of it. But also, like I said before, there's this tendency not to rely as heavily on tooling. There is a lot of tooling out there, but tooling is used differently. The tooling is at the interface boundaries from the language to the rest of the world, where you're like interfacing with .NET, ODB drivers, ODBC? Yeah, ODBC drivers, database type stuff, networking. Those are all, and all those are often baked into the interpreter or baked into the implementation that you're using. So there's been a lot of debate over the years, I think, on should we have a standard library, should it be easily accessible, and there have been efforts to provide that. But in my opinion, one of the biggest strengths of APL is having the idioms supplant most of your library needs. You'll still need libraries here and there, but for the most part, the idioms go a huge way in removing the need to have a set of libraries. So that's a set of tooling that you don't rely on as much. And then so on and so forth. So one of the biggest problems with APL perhaps is that it makes you too productive. And so you end up programming alone.
Well, I mean, it's like, I was trying to do some of this stuff, and
Yeah.
normally I go look at examples of other code, figure out how other people are doing things and what's available to you. Does that exist for APL?
The Fin APL idiom library is one of the classic sources for that. A lot of people rely heavily on that. You can go to Project Euler and see how people are solving the Project Euler problems with J and other things like that. There's the APL wiki. There's the APL news group. Dialog has a forum that you can use to discuss problems.
More on Stack Exchange, actually.
Okay, yeah, so Stack Exchange. I think Dialog runs a North American training workshop type thing.
We've decided not to do those anymore. It's all online.
Oh, okay, webinars.
We're doing monthly webinars now.
Right. And I'm also considering starting a weekly live APL lunch series or something where I just do live coding sessions with people who have questions and go over APL, that kind of thing. So there is the community, but the community is different, I think, partly because the language is different. So it's not the same as like the Python community, but I think part of that is just the language is very different. So it leads to, and there's a lot of old guys who have been doing this for
Yeah, they have
40 years.
They have very old libraries.
Yeah.
That makes them even less interested in developing new libraries.
Yeah.
I mean, there's really a new generation of users coming out now. I mean, the interest in APL, I think, is dramatically increasing. The interest in parallel programming, functional programming, is making APL, although it's nearly 51 years old now, looking much more sane than it ever has.
So I think you had a question?
Yeah, could you talk about the database integration of using APL instead of SQL?
Yeah, so one of the big advantages to working with the array language is that you're able to do in-memory column store databases very easily. And Dialog has a lot of facilities for storing component files or files onto disk.
Yeah, you can memory map, any variable can be memory mapped to an external file.
So you don't have to just store your data in a workspace. If you've got your database in these memory map files, they're out, stored on, you can do duplication, you can do that kind of stuff. You've got file servers.
One of the problems is there's not that many libraries because it's so easy to write your own custom object or column store
Yeah.
that people just build them in a few minutes, right? So you have, basically, you have the memory mapping, you also have a component file storage mechanism, any APL array and write
Yeah.
any number of files.
And then APL is just your query language. So APL very easily maps to things like your, what is it called? What algebra? The underlying relational algebra. It very easily maps to the relational algebra. So if you're writing your queries and you can write a relational algebra expression for it, you can just as easily write an APL expression for it. And you just learn a few tricks about how to best orient your data, and because of the vectorized operations, because of the high-level optimizations you can do about what data you actually need, and because there aren't as many abstractions between you and your data, you can go extremely quickly. And that's where they really shine.
What's the difference between APL and J?
APL was sort of the first iteration of things. Iverson then, my understanding is, wanted to rationalize APL into another set, but this was done at a time before Unicode had really become the thing. So one of the things he did was he took out the symbols and he rationalized APL sort of away from the APL2 stuff and tried to sort of improve on what he felt was the appropriate way of doing APL. And I strongly believe that the choice to go back to ASCII was an incorrect one. But the rationalizations I actually like a lot. And fortunately, Dialog's been doing a lot to get the J features into Dialog APL.
That was going to be my question. I'm going to riff a little bit on that. So, is there any feature in Dialog APL that takes you from a sort of verbose definition to a tacit? As you're learning how to do this stuff, right? I mean, we saw a lot of those tacit definitions in your source.
Yeah.
Right? But is there a feature in Dialog that does that?
You mean like an auto conversion?
Yeah, pretty much.
No, yeah, no. Part of that is because it's an artistic process. It's not a mechanical one. So,
Why would you want that?
No, I mean, I sort of
say is you make it tacit to get a little bit more performance out of the interpreter.
Okay.
And then if you have to debug the code, you run the inverse, unique.
No, that's exactly the word. That's exactly the word that was going. That's exactly the word that I was going for.
Yeah.
That they also, in their sort of propaganda sheet, their documentation, talk about using that from program transformations, right? And so you can create a definition, and because there is a way to convert it into a tacit definition, you can get an inverse on it.
Yeah.
We don't have that. I mean, we have, Roger Dewey, who's the main J guru at the moment. He works 4 days a week for us and 1 day a week on J. So super.
Yeah.
Key, function trains,
Rank.
tally, all these things.
tile.
Were really good, we felt were really good ideas that went into J that didn't conflict with anything in APL, finding their way into APL.
Now, regarding the debugging of trains, I'm actively interested in making that a better process. So in the compiler, I use a poor man's side-effecting printf, basically. It's the identity function that does a printf. But I'm expanding that concept into a full-blown sort of IDE visualization type thing, which you're seeing starts of that with being able to visualize data, animate it, things like that. And I plan to improve that as it goes forward. So in my view, the need to, say, expand out your code a little bit or go back and forth between the representations, I want that need to shrink significantly. So I want you to be able to debug trains as easily as, or really just remove the distinction between debugging and exploration in your code. So I'm actively working to make that easier so that trains become a very, very simple tool to use for people. So, let's see, yeah.
Given that the dialogue program is an interpreter, when you compile your code to GPU, do you manage to turn it completely into a fully on GPU process where there's only data transmitted at the beginning and only data coming out at the end? Or
Yes. So it will never go back and forth in the middle if you don't make it do that. Branching, for example, I don't do on the GPU. So if you use an if statement, for example, inside of a nested computation, that will really mess with your GPU stuff. So if statements need to be on the outside of your GPU computation, and then those will run on the CPU, and they'll have to do a transfer there to do the test because your if statements are running on the CPU. Otherwise, once you get from dialog into the function, it goes all the way through, and it's disabled right now, but there's caching functionality as well, which allows you to get back into the interpreter, do more stuff there, and then go back to the GPU side while having the data remain on the GPU side cached if you don't need to use it on the interpreter, but you're doing something else and you want to go back to that so that you can keep the data cached and keep it on the GPU for longer. And so you can, the goal is to try to keep it as much on the GPU as possible. So I do try to go as much on that. Yes?
So I noticed when I was doing, working through the problems that it feels similar to like MATLAB. In a way, like I took an image processing class in school.
Right.
Or Julia or whatever.
Right.
And it's like, if you basically want to work on the matrices and do all your operations over the whole matrix to get the parallel processing stuff.
Right.
Was MATLAB sort of influenced by APL? Or what is the?
Yeah.
Okay.
I think Mathematica, MATLAB, Julia as well.
Yeah.
But it's this semantics versus syntax discussion, though. I mean, in MATLAB, a column vector and a row vector have different functions to do the same operation on them. And in Julia as well, they've done a whole bunch of things where you've lost the generality of APL.
They've gone the library approach, basically.
It might well make the language more popular because a lot of the problems that 80-90% of the people are trying to solve, MATLAB feels more like the sector. I mean, that's why they have well-designed products from that perspective.
Yeah.
But
Yeah. So I think the trade-off is MATLAB. If you can find the library calls, then you get call, 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 call. Okay, seems to work. With APL, it's much more, you can scale your problems to more specialized domains, or you can explore different approaches, I think, in a more effective manner. So I think it's a better problem-solving tool. MATLAB, I think, is very highly focused on solving pre-existing problems. And I like the fact that APL, I think, is very good for solving unknown problems. And really, I never feel a need to go to MATLAB from APL, whereas I feel like there could be needs to go to APL from MATLAB because of the language is just not as nice. The libraries are very extensive.
Julia is nice though, right? I mean, it's much different.
I think the Julia guys are trying to do some really cool stuff. I obviously have a very aesthetic sense of what array programming ought to look like, and I feel like that's important because I think aesthetics are actually very important in programming. And I think that makes a big difference in how you see the world, how you see problems. So that's a big thing that I think people miss. For example, I came to APL because I tried to implement APL in Scheme. And I was like, yeah, I could do all the semantics. Yeah, it looks all great, but that's not APL. It doesn't feel right. When I work with it, I don't get the same ability to manipulate data in the same way.
I mean, NumPy is also.
Yeah, NumPy is another
also
example.
an APL implementation. You know, Jim Rubunin says APL doesn't like
Yeah.
with parentheses and stuff.
Yeah. And my fundamental claim is that the visual aspects are critical to making a good array language, because you're writing a good math notation, basically. You're trying to find a good way of doing the same type of problems that people develop math notation for. And there's a reason, maybe not good or bad reasons, but there's some reasons why math notation looks the way it does over time, right? And that's a highly optimized notation for expert mathematicians and physicists and scientists to solve real-world problems. It didn't get that way because people think that notation just is, willy-nilly. There's a reason they don't use M expressions or S expressions in that domain. They knew about those things. They could have used computer code-esque stuff, and in fact, they did. Back in the day, you had to write English to do your math. But there's a reason they've switched over to using these other notational conventions in math because of the benefits. And I think that's one of the reasons that I think that's an aspect of programming that people lose sight of when they try to move away, because they're coming from a space expecting programming rather than thinking about how the human interaction works and human-to-human communication. We are. So, yeah.